Lecture number 7, the intermediate code representation for switch statement and function call. Switch statement. The switch or case statement is available in a variety of languages. One of the part is like this. So there is a selector expression E which is to be evaluated, followed by n constant values v1 v2 to vn, and which is always matched with the expression, and the corresponding value cases will run. Now we need to translate it. The intended translation of the switch code is to first evaluate the expression, number one. Number two, find the value of Vj in the list of cases that is the same as the value of expression. Default value matches, then if none of the values explicitly mentioned in class does. Now execute the statement, that is the jth statement. If the vj statement is evaluated and it is correct, it matches, then sj statement will be executed. So what we will do, we will code to evaluate the e into t. So expression e will be evaluated and the result will be stored in t. Go to the test, and l1 l1 for the l1, go to s1, that is the statement. Go to next, I can write, and then for l2 I can write code for s2 statement 2. Next, go to next, and so on. So the corresponding value which matches with l1 will be corresponding statement will be executed. So here the code to evaluate e into t, and then go to test. So I have written here test. So here test, if t equal to v1, then go to l1, so it will jump here and go to next, it will come. If t equal to v2, then go to l2, so it will come here, and so on. I can add if t equal to vn minus 1, so this is the value n minus 1, then go to l n minus 1, otherwise go to ln. So this is the part. So each and every part we are coming to the next. So this is one of the possible conversion. So translation of switch statement. Another one more statement can be, if t is not equal to v1, then go to l. Code for s1, go to next, l1. If t is not equal to v2, then go to l2. So we may write like this also. There are different varieties of alternative. You can write in with yourself also. So this is ln minus 1 and so on. So it's very easy to understand. So how to write this, convert the switch statement. Intermediate code representation for the procedure for the function. Suppose a is an array of integer and that f is a function from integer to integer, and then assignment n equal to f of mi. So array element is passed in the parameter, and it can be translated as follows: t1 equal to I into 4. So let us consider the size of one element is 4 byte, so I can write I multiplied by 4. Now I square bracket, if at the complete address we are getting, and the value is stored in t2. Now param t2, so because the function parameter is a square bracket I, here we have converted and we are getting this value. And now we can call f comma 1, because only one parameter we have. So this t2 will be passed as a parameter and resultant will be stored in the t3, and n equal to t3. In this way we get the value of t3. So first two line compute the value of expression ai in the temporary t2. Line number 3, t2 actually parameter of the call. Line number 4, f with one parameter. Line number 5 assigns the value and return the function. And line number finally in line number 6 we can have the value. Three address code for procedure call. Let us consider one. We have one more function here, add function. In the main function we have v1 v2 v3 to v4, four element, and we need to do all these things. So let us see how it can be done. Function underscore add t1 equal to a plus b, just I have written c equal to t1, so that the a plus b c is placed here, and return c, so c is returned here. So one place is placed, simply I left to by forget that other operations can be written here. Next we have end, so function is complete. Now v1 equal to 10, because two values to be passed, function add v1. So v1 v2, v1 is 10, v2 is 20. Now we can write param v1, so that the parameter first is indicated, second parameter is indicated. Now we can call add comma 2, with 2 indicates that we two parameter is to be passed as a parameter, and the resultant is stored in the t2. and the value of T2 is stored in finally in V3, and this V3 plus 5, because we need to add this part also. So this V3 plus 5, so this V3 plus 5 is here, so we need to implement it now. Finally the resultant is stored in V4 here. So in this way we can have